Good morning, dear girls. Now let us see another practical program. The program is write a program to read and display the data using the concepts of single level inheritance. Single level inheritance means only one class is derived from a base class. Okay, that concept is known as single level inheritance. So here, see, create a derived class that contains marks of two subjects and total marks as the data members. That means here we are going to create a new class named as marks. Okay, from the base class student, and this derived class marks will be having the data members like two subject marks and total marks. Okay, so we'll start the program. Hash include iostream.h, hash include conio.h, hash include iomanip.h. All these three header files, you know why it is used. Correct? Okay. Now let us see the base class. So this is the base class. From this base class only we are going to derive a new class. That new class is named as marks. This is the new class. That means this is the derived class which derived from the base class student. Okay. Now see here, student is the base class. So in this base class we are declaring the student basic details. Okay, and from this student class we are going to derive a new class. So in that new class we can give the details, like now see here we are going to derive the new class named as marks. Okay, so this is a new class we are going to derive from the base class student. So in this marks class we are going to give the student marks details. Understand? So here only one class is derived from a base class. That is why this concept is known as single level inheritance. Okay. Now see, two data members we are declaring here, and in the public declaration we are going to define. We are not declaring, we are defining two member functions inside the class only. Okay, so see, declaration means here you should write void read semicolon, void display semicolon. That is declaring the member function. But instead of declaring, here full function body we are writing inside this member function. That is what this concept is known as. Member functions are defined inside the class. Okay, so here this class student, this is the basic class. The full basic class program will be written inside this class definition only. That means private data we are declaring here, and public data like void data. Void data is same as void get data. So that means getting the details of the student, register number and name, and void display for outputting the register number and name. So these two member functions are written inside the class and closing the base class. So this is the program for the base class. Okay. Now from this base class we are going to derive a new class using the syntax you see here. Class data type, and the derived class name is marks, and this is visibility mode operator. Using this operator we are writing what type of inheritance, like publicly or privately or protectedly we are going to inherit the data from the student. Here we are going to inherit the data publicly. That means now student and marks can access both the details, or this marks class can access the data publicly from the student class. Okay, that is what this public inheritance. Clear? Okay. Now in this marks, this is a derived class. This is the new class derived from the base class student. So this marks class contains the details. Like see, in the private declaration we are declaring the details of two marks and total marks. These are the data members. And again in this derived class also we are writing the member functions inside the class only. That is say void read one. So instead of read, there is one member function we have read, that is for getting the details of the student register number and name. But now here the member function name is void read one. Using this member function we are going to read two subject marks like C in M1 and M2, and instead of using a small function calculate, instead of that here only in the input function only we are calculating total equal to M1 plus M2. That means total marks of these two subjects. Clear? So this is void read one. Can you understand? Read is the member function for getting the details of register number and name. Now the member function named as change, like read one, that is for reading the subject marks, and we are calculating the total of that subject marks. Then void display1. Instead of display, here we are writing void display1. Using this member function, we are displaying subject1 m1, that is marks will be displayed here. Subject2 equal to m2, the marks will be displayed here. Then total marks equal to total. So this three data will be displayed in this display function. Then close the flower bracket and semicolon. This is the derived class definition will be closed like this. Okay, now we'll go to void main, like main program, and using the derived class, and we are declaring an object for derived class. So using this derived class objects, we are going to call all the member functions. Now see, we are derived the class marks from the student publicly. That means this derived class marks. See here, we are derived the new class named as marks. Publicly we are inheriting data from the base class student. That means this derived class marks can access the data from the student class. Clear? Okay. That is what, see, using the derived class name marks, we are declaring an object for the derived class marks as m, and using this object m, we are calling each function. See, m.read. This will read the data from the base class student, that is reading the student register number and name. m.read1. This will read the student marks, like marks 1 and marks 2, and it will calculate that to total of 2 marks. Then m.display. This will display the student register number and name, and m.display1 will display the student subject marks 1, 2 and the total marks. Okay, then get ch close bracket. So this is the program for single level inheritance. Now let us see the output here. See, output, enter the register number and enter the name, then enter 2 subjects. We are entering 2 subjects, and all this details will be displayed. So here what happened, using the derived class marks, we are accessing data from the base class also, and all the functions can be accessed using the derived class object. So derived class is marks, and the object here is m, marks m. We are declared the object like this, see, marks m. So using the object m, we can access all the member function from the derived class and from the base class. Clear? Now let us see the next topic in inheritance, that is visibility mode. The visibility mode controls the access specifier in the derived class, and the visibility modes are private, protected, public. And the visibility mode defines whether the class is defined private or public or protected from the base class. Here you can see the example for visibility mode. Okay, so this is a syntax for defining or declaring the derived class. So using the keyword class, and we are giving the derived class name and visibility mode operator, and here you are writing the visibility mode. That means how we are going to inherit the properties from the base class. You can inherit the properties from the base class privately or publicly or protectedly. Okay, so that is what in this visibility mode topic you are going to explain. So here you see the example. Class is a keyword and marks is the derived class name, and this is the visibility mode operator, and here we are going to inherit the properties from the base class publicly. So this is what visibility mode here we are giving. Instead of visibility mode in the program, we can give either private or public or protected. So in this example we are giving us public. That means we can access the details from the base class publicly to the derived class marks. Okay. Now let us see, if you give private inheritance, that means visibility mode if you are given private. Now let us see how we can access the details from the base class to derived class. Okay, if you are given the inheritance as private inheritance. So see, private members of the base class cannot be inherited. Private members of the base class cannot be inherited. And public members of the base class, when you are inheriting privately, the public members of the base class will become private members of the derived class. Okay, that means this members also cannot be accessed outside. It will become private, public members will become private members of the derived class, and protected members will stay protected in the derived class. So this is the visibility mode when you use private. Clear? Now let us see the public inheritance. That is when you are inheriting the members from the base class to derived class as publicly, how see the members will be inherited. So the private members cannot be inherited to the derived class. Okay. And the public members of the base class can be inherited publicly to the derived class. That means the same concept we have seen in the practical program. The public members of the base class can be inherited publicly to the derived class. That means this derived class can access this base class member functions publicly to the derived class. Okay. Then the protected members of the base class will stay protected in the derived class also. So this is the public inheritance. The last is protected inheritance. That is the base class. From the base class, when you are accessing members to the derived class with the protected inheritance, see, private members cannot be inherited and public members of the base class will be protected in the derived class when you are using protected inheritance. And protected members of the base class will be protected in the derived class. That means we are protecting the data using the visibility mode protected. Okay. The next topic is virtual base class. When two or more classes are derived from a common base class. So which concept there, like two or more classes are derived from a common base class? It is hierarchical inheritance. So when you use this concept, like when two or more classes are deriving from a common base class, then we can prevent multiple copies of the base class being present in the derived class by declaring the base class as virtual when it is being inherited. So such base class is known as virtual base class, and this can be done using the keyword virtual. So when you write the program like that, like more than like two or more derived class will be inheriting from the same base class. So there we can keep the base class as virtual. So that concept is known as virtual base class. Then the abstract class. An abstract class is the one that is not used to create object. So abstract class is designed only to act as base class. So abstract class means we are not creating objects from the abstract class. It will be designed only to act as base class. You know, in our practical program also, after deriving a class from the base class, then from the derived class only we are creating the object, and using that object only we are accessing all the member functions from the derived class as well as from the base class. Okay, so that type of base class is known as abstract class. Clear? So this is very important chapter. In this chapter, advantages of inheritance is important for 5 marks, and levels of inheritance, all the 5 levels of inheritance is very important. Then the next question is explain single level inheritance with a practical program. That is, the practical programs is important for theory as well as for the practical. Then the visibility mode, that is not very important, but then you have to study different levels of different types of visibility mode. Okay.